All right, hi. So for our final interactive advanced concept, I'm going to be attempting these super popular frozen water bottle experiments for the first time. So for the first experiment, I'm going to try to flash freeze a bottle of water. So I have some water bottles in the freezer that have been in the freezer now for a bit. And I'm working in my kitchen so that I can carry them quite easily, and hopefully this works. So for the first experiment, like I said, the bottles have been in the freezer for 2 hours and 45 minutes now. So I'm going to go very gently, pick it up out of the freezer and bring it back to the camera and give it a strong jolt and see what happens. So here's my water bottle. I'm just going to, ooh! So it kind of worked. There's still a little bit of liquid in the top, and it looks like maybe I'm just not jolting it hard enough. Oh yeah, there it goes. So that's super cool. That's experiment number 1. Put that bottle over there now. And then for experiment number 2, I have a bowl of ice here. And what I'm going to try to do, I'm going to have to lower my camera for a little bit for this one. But what I'm going to do is pour one of the other frozen water bottles and see if I can stack the water on top of this and form ice on top of the ice that's already in the bowl. And we're going to see what's going to happen. So here is my second frozen water bottle. I'm going to gently unscrew the cap, and I'm going to lower the camera so that you can see where I'm working. Let's see if this works. Does not look like it's working. Nope, that didn't work. Let's see if a different frozen water bottle. Nope. Okay, so that one didn't work as well as the first one did. Totally fine. I'm just going to move this bowl before I make a gigantic mess. And then for the last example, I'm going to take a water bottle again. Oh, that one was kind of cool. I'll end up lowering the camera so that you can see what I'm doing a little bit better. But for the last one, I am going to pour one of the frozen water bottles into this glass jar here, just a regular glass jar. And then I am going to drop an ice cube right into the center of it and hope that the ice crystals spread and freeze the whole glass. So hopefully this one works. Oops, let's see. Pour that water bottle right in there. Very gently. And then I'm going to lower it again, the camera again, so that you can see the water. So there's my glass. And I'm going to take an ice cube. And I am going to drop it right in. And it does not look like anything is happening. Ooh, it's tremendously cold water though. So yeah, that one didn't look like it worked as well. Save that, I guess I can drink that water. So a little explanation of what we're trying to do here is, if it were to work, what would be happening is that in these 3 experiments, the water freezes in the first example, like we did see actually happen, because the energy generated from hitting the side of the bottle forces the water molecules to form a crystal in a process known as nucleation. And it's a similar reaction, which is what is supposed to happen in the second 2 experiments, which we did not see this time. And that is the super cool water is hitting other frozen objects. So whether it's stacking on top of the ice cubes or mixing the ice cubes in the cup of water. And that is causing the crystallization to spread up the water that's getting poured out. I think what could have possibly gone wrong in my 2 experiments were that I didn't have a metal bowl for the ice to sit in for the first one. I could only find glass bowls in my apartment. And then I think for the second one, some of my water bottles seem to freeze at various points. I think the freezer isn't balanced in how cold the overall temperature is. And I think one side is definitely colder than the other. So I think that played a role in the starting temperature of the water bottles, and definitely then played a role when adding the ice cubes. So cool experiments on the YouTube videos. I wish they were as cool when I recreated them, but I can keep working at it. Thanks.